Hello, this video we will be talking about heat pump. So, what is heat pump? This is a device that transfers heat from low to high temperature. Okay, so it's HP, heat pump abbreviation. It's a device to transfer heat from low temperature to high temperature. A quick example is, imagine if you were this freezing cold weather in Minnesota, and you want to stay in your cozy, warm home, and you would like to have a heat pump, right? Because you want to have a device being able to take the heat from the freezing cold weather to your warm, cozy room. Sure, you might be wondering, if it's freezing cold weather, why do I want to take heat from it? Because even it's freezing cold, it still has heat. Yes, so it still has heat. You can still take out the heat from the freezing cold weather to your warm house. So that is the goal for heat pump. And heat pump will share the same sketch as refrigerator cycle. If you want to learn more about refrigerator cycle, it's in the previous video. So this is our refrige. All we can hear is heat pump. If it's a heat pump, we also have here, it's going to be TH, higher temperature reservoir, TL. We know from refrigeration, we need work coming from compressor, and here we have heat leaking, leaving the system to the kitchen, right? That's going to be TH. And we also have heat coming into the system, QL, from the refrigerator space, right? Taking the heat coming from the refrigerator space. So knowing that, you're looking at this entire cycle, it's basically the heat is coming from low temperature to the high temperature, right? And we have this required, we talked about Clausius statement in the last time, and that can happen with those combination of compressor, and then we'll have condenser coil and throttling valve and an evaporator. So check out the previous one to review that concept. But now, if it's a heat pump, it's just gonna be sharing the same principle but achieve different purpose. Why? For refrigerator, what do we want? We wanted this cold refrigerator space to be really cold. So it's gonna take in the heat out from there into the colder freon, right? But for heat pump will be different purpose. Will be right here. So imagine this is going to be the cold weather blizzard outside. So this is gonna be cold outdoor. And this is gonna be your indoor, your warm, cozy, happy place, you know? So then you want to go from heat transfer from cold, low temperature to high temperature, right? In order to do that, we call this a heat pump. So you want to taking out the heat from the cold environment and then dump that heat to your indoor. So this is your indoor reservoir, higher temperature reservoir. So they are using the same principle, but here, what we are focused on is this side. You want to achieve that. You want to get more temperature here. For refrigerator, it's exact opposite. It's this side we're looking at. We want to take more heat from refrigerator space to the cold freon. Okay, so knowing the difference between heat pump and refrigerator, and knowing they're sharing the same principle, we can go ahead and write down the COP, which is coefficient of performance. Now we're going to write down HP, right? That's a heat pump efficiency. What do we desired? What's desired output? And what would be required input? So desired output would be we want more and more heat transfer to this indoor room, right? So we want more QH. And what is absolutely required? We need this compressor work come in. So that's our equation for heat pump efficiency. COP is equal to QH over WA. And the difference between COP for refrigerator we had earlier, it's for refrigerator, we desire different things. We want to desire QL over required work A. So that's the only difference. Now let's look at another expression for COP heat pump. Because we also know WA required work is going to be equal to QH minus QL. So knowing that, we can substitute that information in here. Then we would have another expression for our COP for heat pump. So that would be it to conclude our heat pump video. And in the next video, we'll look at some examples of both refrigerator and heat pump. See you then. Bye.